Good morning. Now we are going to see the conditional macro. Before that, any body of the macro will not have a label, any kind of label. We cannot have any kind of label in the body of the macro instruction. In the example, we have write buffer which was called twice, and if it has a label, then we had commented that line. So uh, we were not having a label. Usually we should not have a label in the definition of the macro. So these labels are used within a macro body begin. Now suppose we want to have labels in our definition of the macro, then those labels must be preceded with a special character $, and each symbol beginning with the dollar has been modified by replacing dollar with $AA. For example, it is $AA. You can have $BB or $AC or $BB, anything you can have. But where you are going to have the name in the wherever it is referred, then it should be replaced with the $AA. Now, the generation of unique labels. In the previous example, we have seen relative address operands, that is in jump instruction, JEQ and JEQ to a location, that is the relative address was star minus 3. Okay, so I'm talking about the instruction test device followed by jump on equal. So there were two instructions at 140th location, and another one was at 155th location. And when we have this jump on equal instruction, it has to, the first at let us consider at line number 140 we had a jump instruction, and we had written the relative operand as star minus 3. So what is star minus 3? That is the current location minus 3 bytes. That means you are going to jump backward. Okay, so previous instruction was test device. The length of the test device is 3 bytes, and when you have this next instruction jump on equal, you want to go to the previous instruction. That means minus the length of the previous instruction, so it is going to back to the previous instruction. Similarly, we were having another jump on jump instruction, jump less than, wherein the operand was, the relative operand was star minus 14. That means we are going to jump back 14 bytes back. Okay, so at that time we are going to repeat in the loop. So that's what we had seen in the example. And so this example is a small example wherein we can compute that go to the 3 bytes back, or go to 14 bytes back, or jump forward 20 bytes. So when the size of the macro is small, then we can have the relative address operands we can have in the instruction. But it is very this way of writing the jump instruction, it is very inconvenient, and it is error prone, and it's very difficult to read also, because when you say star minus 3, it's very difficult to read, because what it is telling is take the current location minus 3 bytes. So 3 bytes we know, but what it means is not clear. Okay, so that's why it is very difficult to read such instructions. So in such cases, we are going to write special types of labels within the macro instruction. Now consider the example. We have read buffer here, and macro has 3 parameters: ampersand indev, ampersand buffer address, third one is ampersand, record length. So these are the parameters for this macro read buff. And this read buff which has some instructions. So the first three instructions, that is clear X, clear A and clear S. So all these X, A, S are having 0 now when you say clear. Okay, so what is this clear X? It is you are going to store 0 in X register. That means you are clearing the loop counter. Similarly, the second statement tells that you are clearing the accumulator. You are clearing the S registers. So this is the initialization of 3 registers we have in this program. Okay. The next instruction is plus LDT, $4096. So we are going to set the record length as 4096, and this data we are going to store in T register. So LDT stands for T register is loaded with 4096, and it is a format 4 instruction because LDT is preceded with plus symbol, and that indicates it's a format 4 instruction. Also, the operand is present in the instruction that indicates that the addressing mode is immediate addressing. And then we have the next statement, that is a test device, and the test device is having a label on the left hand side. So this label part in the macro definition should be preceded with $. Okay. And then we have jump on equal $loop. That means wherever the label is there, that the label should be preceded with a $. symbol. And then we have read instruction, and wherein we are going to read the information from the input device, and then we are going to compare the contents of A register and S register. And next statement is JEQ, and if A and S are equal, then we are going to jump to a location exit, and since this is a label, so it should be preceded with $. symbol. Next we have STCH statement, wherein we are storing a character which is present in the accumulator at location. The location is specified in the instruction, that is buffer address plus the contents of the index register. Then we are incrementing the index register by 1, and we are going to compare this X with T register, contents of the T register, and if it is the contents of index register, if it is lesser than the content of T register, then you are going to jump back to a location $loop. If not, you have to calculate that address and you have to put here, but instead of that, this loop will specify that this is a symbolic information we can put in the instruction. So you can say this loop jump on less than, which the control goes to the location which is specified by the symbol loop, and this is a label, and since the label, any label should be preceded with a $. symbol. And the next statement is STX. The contents of the accumulator is stored at location record length. So we are going to the contents of the index register, in this case it is a index register, we are going to store in record length, because every time index register is pointing to different location, and that location specifies the length of the record, and that we are going to store it in length of the rec length variable. And next statement is mend. So this is about generation of unique labels in read buff macro. So wherever you have a label, those label must be preceded with $. symbol. Then we are going to see how this read buffer is called. So read buffer F1 buffer length, and when the call is made to this macro, then this macro call should be commented. That's why there is a dot on the left hand side. That means this macro call should be commented. It should be commented, and then we are going to place those set of instructions which are present in the macro definition. How you are going to get that? We know that in the data structure, that is defined table will be having the set of instructions which are there for that macro. So from there you are going to place that wherever the macro is called. So now we are going to have this clear X, clear A and clear S. Then we have instruction plus LDT 4096 as it is. Then we have TD, and which is having a loop there. So where it is called, then this loop should be preceded with $AA. Okay, so jump on equal is $AA loop. And next we have similarly jump on equal, that is 70th statement, jump on equal, that is $AA exit. So the first call we have replaced with the $AA and followed by the name of the label. Now we are going to see conditional macro expansion. So we can write conditional macro using if statement, and we are going to take an example for this read buffer. Read buffer we have seen in the previous example, which is having 3 parameters. Now 2 more additional parameters we are going to have, that is %EOR and %max length. The macroprocessor directive set is used in this case. The set statement assigns 1 to the end of record check. Another symbol we have end of record check. And the symbol end of record check, that is end of record check, is a macro time variable which can be used to store working values during the macro expansion. So we are going to take 3 macro calls: read buff, F3, buff, reclel, then 04, 2048, and second call is read buffer, 0E, buffer length, and there is no parameter for this EOR in this case, and the last parameter is 80. Then we have read buffer, F1, buffer, R length, 04, and the last parameter we are not going to read. So there are 3 macro calls with the arguments specified in this example. So first we are going to see how we are going to have the conditional macro. How we are going to write a conditional macro. So read buffer as usual, the name of the macro. Then we have 3 parameters in this conditional macro: indev, buffer address, rec length, EOR, max length. So these are the 5 parameters which are preceded with the ampersand symbol. Then the first if statement we are going to have here the condition: if EOR is not equal to blank. The first if statement what it is having is if EOR, that is end of record, is not equal to a blank character, then we are going to set this EOR CK to 1. So ampersand EOR CK, we are going to set that equal to 1. That means EOR CK will be having 1 and the end of the first if statement. Then as usual we have clear X statement and clear A statement. Then we have the next macro which is defined in this read buff is if end of EOR CK equals to 1. Now previous case we have checked with the EOR with blank space. Now which has set this EOR CK equals to 1. Now in this case we are going to see whether URCK is equal to 1. If it is equal to 1, then we are going to load that whatever is present in EOR, we are going to load it in A register, and that we are going to move the contents of the accumulator, we are going to move to a register S, and then end of if statement. Now next if statement is, if the max length is equal to blank, that means if we have not read the last parameter, if it is equal to null means what? The last parameter we have not read. So at that time we are going to set the default max length, that is 4096, and that quantity we are going to store it in T register. Else we have read the max length, okay, and that we are going to store, that max length quantity we are going to store it in T register, and the end of the if statement. Next statement is a test device. You are going to test the input device, okay, and if it is equal to loop, if it is equal, then we are going to loop back, okay, jump on equal to a location loop, and if it is not equal, then we are going to read a character from the input device. And next statement is, if end of record check equals to 1. If it is equals to 1 means we are going to compare this, that means EOR is having some character which indicates, if you have read that character, that means it is the end of the record. Okay, so EORCK is equal to 1, then you are going to compare the value of accumulator and the register S contents, okay, and jump on equal to exit statement. So you are going to go to, if contents of the accumulator and contents of the S register is equal, then you are going to go to a location exit, okay, and end of statement. If not, the age value is different from S register's value, then you have to store that character into the location buffer address plus the contents of the index register, and then we are going to increment this contents of the index register by 1, and you are going to compare with T register, that is done by TIXR. TIXR stands for increment the value of index register and compare that with the T register. So in this case we had some value, that is, let us initially X will be having 0 because we have cleared X, and X is now, after executing this TIXR, it is going to have 1 now in the X register, and the 1 is compared with whatever is there in the T register. If it is less than, that is jump on less than, it is going to go to looping. That means the next character we are going to read from the input device. If not, the last statement is, we are going to, like this, we are going to read so many characters from the input device, and we are going to store at a location buffer address plus X, okay, and we have stored all these characters which are read through the input device. Now X will be pointing to the last character whatever is read, and that means the X register will be having the location of the last character which denotes the length of the record, and that we are going to store, that is STX rec length, means store the contents of the X register in rec length. So you are going to store the record length. Now with those three macro calls for this read buffer, we are going to substitute these arguments, and thereby we are going to substitute wherever we are going to substitute those set of instructions in the macro call now. Okay, so the first read buffer was taking that is 5 arguments. The first argument is F3, second argument is buff, third argument is rec length, fourth argument is 04, and fifth argument is 2048. And since this is a macro call, now we are going to replace those set of instructions which are there for this macro definition read buff Okay, and that's why this macro call should be commented. That's why we have the dot on the left hand side. Okay, so now we are going to place those set of instructions where those are present. We have already stored in the definition table, def table, and from there you are going to take those set of instructions and we are going to place in the place where the macro is called. So the first instruction is clear X, then clear A, then LDCH04, that is LDCH04, that is we are going to set the character, that is 04. 04 is the which is stored in the accumulator now. Okay, so 04 is the fourth argument, that is end of record. That means what? If you read 04 through the keyboard, then that indicates no more characters you want to read, so you want to go to last statement. So first we are going to store that is 04, which represents in this argument, this is 04 is the argument, that argument for the parameter EOR, end of record. So EOR is having 04, and that character is that is 4 is loaded in the accumulator, and next statement is at 40th second location, register move, that is the content of a accumulator to register yes. So accumulator is having 04 and you are going to move this 04 to register yes. So register yes will be having 04. Next instruction is LDT plus LDT 2048. That means you are going to store that is 2048 in T register. So the maximum record length we are going to store it in T register. Next statement is TD, and we are going to read from the input device F3, which is specified as an argument in the call, read buffer call. So we are going to read from the input device F3. Next statement is JUQ, so we are going to loop back if the device is not ready. Then we are going to read a character from the input device F3, and that character which is read through the input device, which will be loaded in accumulator. Now accumulator is having the character which is read. Now compare the accumulator contents with the S register. Now you remember that S is having 04 and A is having the character which you have read now. Let us consider A is read through the keyboard is say 5. So 5 is compared with 4 and there is no match. If it is matched, then you are going to go to the last statement exit. Okay, jump on exit, $AA exit. Now since A is having 5, let us consider 5 and S is having 4, so it is not going to go to last statement. So we are going to store this character A, whatever is there in A, at location buffer plus the contents of the index register. So 5 is stored at location, target address is computed as buffer plus contents of the index register. In that location we are going to store whatever is present in accumulator, that will be stored at that location. After that, index register is incremented by 1, that is X is incremented by 1. Previously it was having 0, now it is going to have 1. 1 is compared with the contents of the T register. T register is, in this case we have in the call 2048, so it is comparing 1 with 2048, and if it is less than, it is going to jump back to the previous loop, that is loop, and thereby you are going to read the next character. So this process is continued. So it may go to so many characters it is going to read, that is either it may read 2048 characters and it is going to store at location some buffer address, at location buffer address. If not, it may not be 2048 characters, but if you have read any value, that is 04, and then you are going to stop there and you are going to go to a last statement. So either you can have maximum, you can have 2048 characters, and minimum it depends on at what time we are going to read 04 into the accumulator. That time it is going to come out of this loop. Next call is for this read buffer call is 0e buffer length, then empty, and then 80. So EOR in this case is empty, that is blank, okay, and the maximum length is 80. Now this also is commented, and in this location wherever the macro is called, we are going to place those set of instruction. So as usual, clear X, we are going to clear the register S, then clear A, you are going to clear the accumulator, then we are going to load this max length into the T register, and then test device we are going to load, that is we are going to poll the input device, and then we are going to, if it is equal, then we are going to go back to the previous statement, that is TD. Again you are going to test the device. If it is ready, then we are going to read the one character from the input device OE 0E, and that character we are going to store, that is STCH. The contents of the accumulator is stored at location buffer plus the contents of the index register. Okay, the target address is calculated by buffer plus the contents of the index register. And next statement is TIXR, that is increment the contents of the index register and compare with the T register. T register is having 80, so 1 is compared with 80 and it is less than, 1 is less than 80, so it is going to go back to the loop, that is AB loop, and this process is continued. And once it comes out of this loop, at that time it is going to store the length of the record, which is X is pointing to the last character, whatever is read, and that indicates that is the last character which is read, and that length that will be considered as the length of the length, and that value whatever is present in X register we are going to load it in length. So the third macro call is read buffer F1 buffer R length, and now EOR is read, that is 04, but max length is not read, so the last parameter is not read. So now how this macro, conditional macro, is going to work now? So this should be commented, that's why on the left hand side of this read buffer we are going to have dot, that means this call is commented now. Then clear X, clear A, then load the accumulator with 04, that is end of record. EOR is loaded in accumulator, and that accumulator contents is moved to S register. So S register is having 04. Okay, then next statement is load the T register with 4096. Then test the device, that is the input device you are going to poll, that is F1. Input address of the input device is F1, and that you are going to poll. If it is not ready, then you are going to be in the loop, jump on equal to AC loop. Then if it is ready, then you are going to read a character from the input device F1, and then that read character now it is present in the accumulator. So the contents of the accumulator is compared with the contents of the S register, and if it is equal, then you are going to move to a location exit. If it is not, then that character which is present in accumulator you are going to store in a location which is the target address is computed by buffer plus the contents of the index register. So again you are going to increment the index register, compare with the T register contents, and this process is repeated until we read all the characters, that is 80 that is 4096 characters. Either the maximum length of this record will be 4096, or wherever it is a reading, that accumulator is reading, accumulator will be having 04, at that time it is going to stop. So that record length we are going to store it as a record length. So whatever is pointed by X register, that is 90th location, whatever is pointed by X register, that will be considered as the length of the maximum length of that record. So we are going to store that quantity in rlen.